Let's begin. Today's August 5th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 9, 14, 17, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we have criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, our triangle digit, and the Turing Machine will let us know whether that value is an even digit or an odd digit. Criteria card B looks at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3, perhaps 2, maybe even all 3 are 3? Criteria card C will look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute smallest. So should triangle be the smallest, should square be the smallest, or should circle be the smallest? Criteria card D looks at the 3-digit solution and will let us know how many of those digits are even. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. And finally, criteria card E will let us know a little bit about the structure of our 3-digit solution, specifically if there's a pair, as in the example 131, or alternatively, there is no pair. And there are a couple of scenarios. One where all the digits are distinct, as in the example 134, or all digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find a unique 3-digit code that abides by all the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card A. I want to know whether that first digit is even or odd. Okay, so the Turing Machine does not approve of my choice. I did pick an odd 3. So since it does not approve, it's letting me know that, yeah, that first digit, triangle, must be an even digit. So let me go ahead and type that up in my notes for section A. Triangle is an even digit. And since it is even, that means it cannot be odd. So let me go ahead and cross out all of the odds. So cross out 1, 3, and 5. Okay, so the next thing I want to test is criteria card E. I want to know if there's a pair or not a pair. Okay, so this time the Turing Machine does approve of my proposal. Remember that I do have 314. They are all unique, meaning that there is no pair. So let's go ahead and type that up in section E, that the solution has no pairs. Okay, which means that they are all distinct. So notice that because I already have an even in triangle, that means that if there is another even, it would have to be a 4. It can, or I take that back. It just can't be duplicated, right? There would be a 2 and a 4. If there were 2 evens, which we do have a card, a criteria card D, that will let us know how many evens. So that would be an interesting card to play since I already have an even. Obviously there can't be 3 because there are no duplicates, and obviously no evens is not possible since we already know triangle is even. So it is a 50-50. It would be nice, I guess, to know whether we're dealing with another even, and then obviously the third digit would have to be odd. So that would be pretty good going into round 2. Yeah, let's go ahead and test criteria card D to see how many evens there are. Okay, so the Turing Machine does not approve of my single digit. Notice I do have two odds to a single even digit. And so the one even digit is insufficient. So in fact, there are two evens based on what I just described, that there's no duplicates. So at most we'll have two, and we already have the one. So yeah, let's go ahead and put that in our notes that we're going to deduce technically, because the only thing we confirmed is one is not correct. So we'll deduce that there are two evens, and specifically 2 and 4, and then an odd. So that means that either square or circle is the other even, and the other one being the odd. Well, that does it for this round. We did complete our 3 Turing tests. Next, we'll be going into the phase where we'll be discussing how to construct a good second round proposal. So yeah, I wasn't able to cross out anything because we don't know which one yet is even or odd. We do have, obviously, like I mentioned, we didn't test how many 3s there are, nor which is the smallest. So if we have, as far as odds go, we know 1 is a possible smallest digit, and if it's not 1, it would have to be a 2. And as far as odds go for criteria card B, either the 3 is there or it's not. So that'd be interesting. If it's not, then how do we conclude whether, I guess we would know, well, 5 can't be the smallest, but it could be, 2, 4, and 5 in some combination, or if there is a 1, it could be the smallest. My guess, well, it's only a guess at this point, is that maybe there is a single 3, and somehow it's 2, 4, and 3 in some combination. So notice that other than, yes, we are mentioning square and circle in criteria card C, but the other one is not mentioned. So somehow square or circle would have to be forced somehow. So that's an interesting scenario. How can we define square and circle to either be the smallest or, even or odd? So, okay, so maybe criteria card B does tell me that I do have a 3. And I guess technically the 3 could not be the smallest. Again, if it is a 3, because that wouldn't be true. A 2 would be the smallest. So it could be that, yes, there's a 3, and the smallest between square and circle would be the even, and then the other would be the odd, and then finally triangle would be the 4. So it could be that triangle is 4. So let's do that. Let's try, we'll say, let's see, but how would we know which one? Well, the smallest would have to be the other 2. Yeah, there's an even. So yeah, so let's do that. Let's say 4, 3, 2, and we'll say that circle is the smallest. Let's see. What if triangle is the smallest? If that's 2, yeah, I guess that's possible too. Triangle could be the smallest. Huh. Yeah, I don't see how we can escape it. Well, let's see. I think we may be able to work it around where if we don't identify the smallest, but how would you, and if there is a 3, we know that 3 is not the smallest, but we also don't know which one's the 3. So I gotta believe that 2 cannot be the smallest, because I think you would have ambiguous solutions. Because, yeah, you wouldn't know which one's 3 or 4. So I'm pretty sure triangle is not the smallest. It's either going to be square or circle. And if it's not one, it's the other. So I think we're safe there. And I guess that would mean that, yeah, triangle is 4. So I'm going to do 4, 3, 2. And we'll see where that takes us. All right, so first, yeah, I want to test which one's the smallest. I want to see, I want to test criteria card C. Okay, so yes, it's true. Circle is the smallest. So let's go ahead and type that up in our notes. And that is C. So we'll say circle is the smallest. Okay, so obviously it can't be 5. It can't be 5. And we're still really debating whether there's a 3 or not, so it could be a 1. But I don't think it would be a 1. If circle's 1, then the other 2 are evens, and there's no way to distinguish between, which one is 2 or 4. There's nothing in the code that would let us know. So I'm almost positive, yeah, it can't be a 1 either. Okay, and probably not until, let's see, and if there is a 3, yeah, obviously if there is a 3, we definitely know there can't be 1s or 5s. And oh, that would be interesting. Yeah, and of course, yeah, 3 wouldn't be the smallest. Yeah, so that would mean that, and neither could 4. So yeah, I think it's gonna come out true. Can I stop here? Can I know for sure? Yeah, I gotta say that it's gotta be a 2. Let's see, if it were 3, and it's the smallest, yeah, that can't happen. It's gotta be the 2. So the question is, and I think I crossed out 1 because that would give us ambiguous solutions determining triangle and square being which evens. Yeah, I think I can deduce that it's a 2. Yeah, because we already sort of determined that there are 2 evens. Yeah, I'm going to go with it. I'm going to say that. Yeah, you know what? I think that's it. Because if I deduce that circle is 2, triangle is the other even, and so square has to be, yeah, square has to be the odd. Well, let's see. Okay, so no, I think I cannot deduce that square is 3. I can say it's not 1 or 2, but not necessarily that there's a 3. It could be a 5. Yeah, so I think I still do need to test whether there's a 3 or not. Okay. And, well, yeah, I guess what I can say is triangle can't be 2. So we're dealing with either 432 or 452. Yeah, I can't just assume that square is 3. So let's go ahead and test criteria card B. I do have a 3. And yeah, okay, so it did turn out to be a 3. But I don't know if I could have, just deduced it. Okay, so let me add in my notes here in B that there is a single 3. Three-digit. And yeah, so yeah, I think, yeah, that's the solution, 432. Okay, let's type it up. And let's go verify. All right, so 432, and there we go. Okay, awesome. Let's go see how we did versus the Turing machine. So what did we test? Okay, so we did A, D, E, and the first 2 were incorrect, and then we tested the remaining 2. So we did 5 overall, which is a good indication that we beat the Turing machine. So let's go type it up. A, D, E, and the first 2 were wrong. A, D, and then E, and then B, C were correct. Okay, yeah, so we did it in 5, the Turing machine did it in 6. So I really do think, again, perhaps the first 3 criteria cards really set us up, knowing that we did have a 2 and a 4 and a third, or the third digit was odd. So that really, I think, helped us out. And I think we just got lucky with circle being the smallest, and then everything else kind of fell into place. So it was a good solve. So I like I've mentioned in other videos, I really do enjoy how some of these cards combine to give unique solutions in very novel ways. Well, what did you think? Add any thoughts to the comments. If you liked the video, please give it a thumbs up so that more people can find the channel. And if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.